Hello again, I'm Gleb and this is my 5G course on IoT Understanding channel. Today I'm going to talk about 5G indoor aspects. As we all know, 5G is becoming a new reality in our lives as more and more operators launch their networks. But at the same time, most traffic are still generated inside buildings, indoors. So that's why today I'm going to talk about 5G indoors with challenges, with changes, with backbone capabilities. And in particular, I'm going to cover such topics as passive distributed antenna systems as a solution for 5G indoors, active distributed antenna systems, or digital DAS. Of course, I will touch such topics as MIMO and beamforming techniques for possible 5G indoors. And of course, I'll try to compare which type of network should you deploy or not to deploy based on 5G C-band or millimeter waves, or maybe we can go with a dynamic spectrum sharing solution for launching your 5G indoors. So let's get started. Okay, let's start with passive DAS solution. Let's suppose that you're going to implement your C-band 5G networks into your current passive DAS solution, which operates on 4G frequencies such as 2.6 or 2.1 GHz. In this case, most of your passive elements will need to replace because combiners or couplers, they will not meet requirements for standing wave ratio, that will not meet requirements for pass losses, for coupler degree, let's say. So it means that you will have to replace most of your passive elements in order to support new high band. So what else important to emphasize? It is the introduction of new, much more wider signal into your current network, which is usually contains not only LTE but also UMTS and GSM in indoors. All of that, it will cause passive intermodulation, possible passive intermodulation. This is additional negative side of implementation C-band for your current passive DAS solution. What else important to say? Of course, pass loss. C-band operates on higher frequencies, so that's why you will have to compensate additional 6 or even 10 or 12 dB in downlink direction. Let's suppose that we can compensate. We can pump up our radio units for such values. We can find much more powerful radio units, yes, to compensate pass loss in downlink. But what about uplink? In uplink, it's almost impossible to compensate such differences. Users, they expect multi-gigabit per second experience, especially for indoors, because 5G, it is all about indoors. It is about gaming, it is about healthcare, industrial cases. All of that happens indoors, and most of the traffic generated indoors. With all of that negative aspects of passive DAS, it will be absolutely impossible to implement C-band 5G into your current legacy network. From my point of view, if you would like to introduce 5G into your indoors, which operates on that solution, it is better to go with two ways. You can go with dynamic spectrum sharing to share 5G resources with your current 4G frequencies, or you can deploy a dedicated 5G low band signal which operates on sub 3 GHz. Both of that solution is relatively the same because relatively the same bandwidth, the end user experience would be the same, but it can be really good as a kind of a starting point, as a kind of introductory of 5G to your customers for indoors. So it was passive DAS. Okay, let's briefly talk about active distributed antenna systems. Basically, it looks like this. It has the signal source as a radio unit. It may have feeders with all passive elements such as splitters, combiners, couplers at this point. And at the end of such solution, it basically contains signal transformative to optics to antennas, multiple antennas. So the final feeder line was replaced by optics with active antennas. So that's basically the difference between active DAS and passive DAS. But in reality, active DAS, it keeps almost the same problems as passive DAS. It is hard to support C-band. It is hard to introduce new C-band in your current legacy active DAS network. As I said before, some systems may have passive elements, so it's hard to find passive elements with support of C-band and higher frequencies. Next thing, it is tremendously hard to support high order modulations. Of course, we can deploy 2x2 MIMO, but when it comes to 4x4 or higher order MIMO, it will be extremely difficult because it will require to plan to design absolutely the same branches, absolutely the same feeder lines, passive elements and optics in order to have these similarities, absolutely similarities between each MIMO branches to keep signal noise ratio at the same level for all branches. So in this case, active DAS will keep the same negative aspects of passive DAS. It is still very bulky solution, very complex solution for implementing it into airports, into big shopping malls, because you will have to accept and negotiate all of that with building owners, with multiple constructions it requires. So, and in addition to that, in case of trying to launch C-band 5G network with your current active DAS solution, in this case, it requires much more investments, additional investments in your network in order to have the same coverage with your legacy network. Of course, it will lead to much more power consumption, so more radio units to compensate past loss, to cover the same areas. So all of that will lead to power consumption. Active DAS and passive DAS, it is very bulky solution, especially when it comes to MIMO technologies. When it comes to antennas for passive DAS and for active DAS, antennas is just usually omni antennas or maybe directional antennas, but there is no beamforming. And we know that beamforming in 5G, it is the key feature in order to get real multi-gigabit experience. Such solutions, they cannot support beamforming. They really hard for them to support high order MIMO. Basically, again, even with active DAS, even with optics and active antennas, it is better to deploy your 5G for low bands as introduction of 5G to your network, or use dynamic spectrum sharing to share your 5G signal with your current 4G signal. We can see that active DAS and passive DAS not so well support the introduction of 5G networks. And now let's consider digital DAS and other solutions for your 5G indoors. And talking about digital DAS or feederless solution, we can see on that picture that such solution does not contain any feeders, any passive elements. It has baseband unit for signal processing. It has optics connected to a radio hub or radio indoor unit, we can say. It also connects to multiple kind of a small cells with active antennas. This is multiple, we can say, radio dots or pica RRU units. And of course, such feederless solution, first of all, it is easy and fast for deployment. It basically consumes less power that distributed passive does. It is very flexible in terms of implementing higher order MIMOs, because each of that radio unit, it can be 2x2 MIMO, and let's say each of them is 2x2, and we can use distributed MIMO and turns it into 4x4 MIMO using two different small cells, kind of a small cells. 2x2 we can turn into 4x4 MIMO, so very easily. What else we can do? Because we use optics and small cells with active antennas, we can even in a programmable way we can shift handover borders between each cell. We can configure very flexibly. We can, for example, assign this will be one cell and these 3 units will be another cell. We can shift borders very easily without any very complex reconstructions, without any additional passive elements. Of course, we can introduce your 5G C-band using that solution. You will not have any difficulties with uplink downlink imbalance because such system it's really feederless system. There is no passive elements, there is no problems with intermodulation interference. I'm talking about passive intermodulation interference. So this is probably one of the possible solution, or almost the one solution, the first solution for 5G C-band introduction to your indoor system. Well, right now let's talk about millimeter waves for indoor scenarios. Basically, there are a lot of skepticism about using millimeter waves for indoors. But I want to say that there are lots of buildings, modern buildings, which is made out of dry walls, which contains multiple reflective materials such as whiteboards, metal doors, metal constructions in ceilings. All of that, it can create the reflection, the special environment for millimeter waves. So I just want to emphasize that millimeter waves can be suitable even for indoor scenarios. So let's talk about that aspect. Of course, talking about millimeter waves, we should bear in mind that it is about very high pass losses. So this is definitely not the distributed antenna system story. Millimeter waves is not suitable for that. Millimeter waves is not suitable for our traditional solution when we can get a signal from outdoor to indoors. Yes, that also not suitable for outdoor to indoor scenarios, which is usually 4G networks, for 3G, 2G network. Yes, we can say that millimeter waves can be used for fixed wireless access, but when it comes to fixed wireless access, it is usually only for very local, very small cases, such as houses, or not so big B2C customers. I just want to say that fixed wireless access is not suitable for huge indoors, such as airports, huge shopping malls. So in this case, millimeter waves also not a story. But millimeter waves can be used in small cells. In small cells, actually, they can support beamforming. Small cells, they usually support high-order MIMO techniques. And with all of that, we can say that millimeter waves in the form of small cells, it is very good for providing indoor coverage for hotspots, for indoor hotspots inside airports termination, inside different huge buildings. Maybe for private networks is also possible for huge areas for indoors. And at the same time, such small cells, due to millimeter waves, due to small form factor, such small cells, they have a relatively lower power consumption and very competitive size. I mean, very small in size. Basically, such cells, if we are talking about 39 gigahertz operations, such small cells, they even can be handled by one hand. So just like very small box, and it's easy to maintain. It's easy to for constructions, for buildings. So it is the real solution. It is the real solution, and I think we should forget about skepticism for millimeter waves and indoor scenarios. So it was my short lesson about 5G aspects of indoors networks. If you like that videos, you can like and subscribe. So goodbye.